Imagine getting one of the coolest superpowers ever, an ability to teleport. I have no doubts you'll immediately want to travel from your dull office to a warm, sunny resort. But don't rush. Mind that after the very first leap, you can find yourself not on the Mexican seashore, but in the cold vacuum of space. That is, if you aren't blown to atoms. And the trip can seem to last an eternity. In the real world, even having access to super technologies and superpowers doesn't guarantee that you can instantly move from one place to another like sci-fi movie characters. But we'll try to make this whole thing work. In this video, you'll find out how can teleportation kill you? Why are rocket engines indispensable even for a superhero jumper? And can we make teleportation work in the real world? For starters, let's see why teleportation is not an ability you'll be excited to have. Let's pretend you've got the same power that Nightcrawler had in X-Men. According to comics, he goes into another dimension first and only then leaps to the final destination. Plus, his ability works within just a few kilometers. However, this would lead to a very unpleasant side effect in the real world. Even though the jump lasts no longer than a second, this moment will be enough for Earth to leave dozens of kilometers behind. Let me remind you that it revolves around the sun at 30 kilometers per second. So you and Nightcrawler will transfer to a neighboring city instead of an adjoining room at best, and to outer space or deep under the land's surface at worst. What can we do about it? If you want to use this superpower in real life and not get in trouble, you'll have to lug around a special supercomputer. This machine will help you predict the exact position of Earth at any point in time and fine-tune your jumps. But if you want to teleport farther than Nightcrawler, to, say, the other side of the world like the guy from the Jumper movie, your adventure will be ruined by inertia. That's because Earth doesn't only revolve around the sun, it rotates on its axis too. That means that the planet's surface, together with all humans, trees, and buildings on it, is in a state of constant rotational motion. At the equator, it reaches a maximum speed of 1,670 kilometers, but this figure is way lower at other latitudes because of our planet's shape. And if you wish to jump, for example, from New York to Brazil, the speed difference will be almost 400 kilometers per hour. The equatorial moment of inertia will slam you into the nearest wall faster than Formula One cars go around the track. That's because the teleportation superpower doesn't imply an ability to instantly slow down. So, apart from the navigational supercomputer, you'll also have to carry rocket engines on your backpack to eliminate the difference between your speed and that of the Earth's surface. You'll have to teleport to a point high above the ground so that the engines even have time to help you at all. Next, you'll be parachuting back down for quite a long time. I know, that's not what the teleportation sales promotion promised you, but hey, science fiction offers some alternative options. Can we instantly teleport in real life using special gates? That's what the Stargate movie characters were using. They traveled through portals that aliens had built all around the galaxy. You can see the apparent problem. If we want to get anywhere using such gates, they should already exist at the point of arrival. Meanwhile, even with the most advanced technologies, flying to our sun's nearest neighbor, Proxima Centauri, will take at least 19,000 years. Personally, I'm not going to wait that long. So let's try and build a network of gates here on Earth to dash between resorts anytime we want. Stationary portals won't have the problem with inertia and the planet spinning. Besides, Albert Einstein proved the possibility of interdimensional movement back in 1935. You're looking at wormholes able to connect 2 points in space-time located very far from each other. To create one of these, you won't need much, just to produce more energy than comes from the sun. Okay, then let's equip a wormhole with an ultra-powerful fusion reactor. Is it gonna work out now? I'm afraid not. According to Einstein's theory, if you attempt to enter it, a wormhole will either irradiate you with a fatal dose or explode with the force of an atomic bomb. Well, who knows? Maybe one of your atoms will indeed reach some of the resorts you dream about. And even if you put on some extra protective armor able to save you from all of these things, a small wormhole will anyway have the properties of a black hole and spaghettify you in a second. And trust me, you won't enjoy this process since, according to one of the theories, the gate will also stretch time itself, so the adventure will not seem instant. Quite the opposite. You'll feel like it drags on endlessly. It's an excellent way to go insane, as it happened in one of Stephen King's stories. The only way to avoid these problems and remain more or less healthy after the teleportation is to create a wormhole as big as a quarter of our galaxy. But we must certainly keep this monster far away from Earth unless we want to see it torn to pieces. So, a journey to the portal will take as much as flying to Proxima Centauri or more. And this downgrades us from cool stargazers to regular astronauts who will have to waste ages when going on vacation. Does it mean we should quit and settle for good old air travel? Luckily, science fiction suggests another means of teleportation, and this time there's no lethal inertia or giant explosive wormholes. Could teleport transmitters be of service? In the Star Trek franchise, characters use this device to instantly move between spaceships and planets. The transporter rips apart human atoms and then reconstructs them at the final destination. Not immediately, but quickly. But hold on, is it just me, or does this thing really look like a suicide booth from Futurama? As a matter of fact, you die the moment the transporter tears you apart, and then you come back to life when it fixes you later. So, you'll have to complete a euthanasia consent form before setting off for a resort. Holidays ruined. But it's not only legal aspects. The problem is, even having all the paperwork done, you still can't be sure that the travel agency will assemble all 7 octillion atoms of your body right. When working on your brain, one tiny mistake will make you a completely different, if not disabled, person. If you want to get insurance, the teleportation cost will skyrocket in no time, of course. And if at least one little fly gets into the cockpit, well, I'm sure you know this story. But let's assume that we've put fly traps in the lab and even managed to ensure passenger safety. What comes next? The file size containing information on the accurate molecular composition of a human body will be a number followed by 42 zeros. That's way more than all the storage devices made on Earth can hold. And besides, sending this much data will take incomparably longer than our universe has even been existing. But even if you connected the teleporter to an incredibly huge and powerful supercomputer, solar activity will increase, and I doubt you'll flop down on your favorite beach before Earth turns into a scorching desert. It feels like fantastic teleports only cause new problems instead of solving our old ones. But what about real scientific means of teleportation? How can we improve the already existing means of instant travel? Quantum teleportation is no longer a fantasy. When scientists manipulate a particle in the state of quantum entanglement, the other one immediately changes as well, regardless of how many meters or light years separate them. Although you can move just one particle at a time. If we use this method to teleport a human, it will be like shooting deadly lasers through their bodies, slowly and painfully. At a certain point, your head will still be screaming in pain on one side, and your body will be running around like a headless chicken on the other. If we want to teleport a person in one piece, we need to give them the properties of a quantum particle, which opens up a new possibility. This is teleporting via quantum tunneling. At any point in time, electrons and similar particles have a chance to instantly move through any solid barrier. However, if a human-turned particle wants to go to Mexico for a weekend, we'll need not just one, but a few million walls, with the last one leading directly to the beach. By and large, this fantastic ability will maybe let you tunnel your way into a nightclub bypassing the bouncers, but that's it. Since the chances of the tunnel effect working out are slim, you'll have to stand at the walls for hours until you succeed. A Mexican resort, they said. It'll be fun, they said. And you couldn't even make it to a party in time. I'm getting the impression that we won't learn to teleport in this lifetime, but perhaps it's for the best. Many philosophers are worried that the human mind won't survive this trip. They're sure that if we split someone's body apart, their consciousness, or if you like, the soul, may be lost forever. Your body will end up possessed by an entirely different personality on the other side of the gate, and who knows what this new you may be up to. Drop a comment and tell us if, in your opinion, teleportation is worth so much risk, and which of the mentioned techniques you find the most realistic.